Welcome to this YouTube channel. In this video, we are going to see 33 kV to 11 kV substation transmission line, incoming and outgoing feeder. This is the disclaimer. Stay away from the hazardous area of the electricity. Use precaution and safety gloves before handling any electrical instrumentation. Let's get started. This is single line diagram of a MSCDCL Dindori substation, 33 kV to 11 kV step down feeder line. This is the old version of a SLD single line diagram of a circuit. This is the new SLD of the Dindori MSCDCL transmission line. In this video, we are going to see the following components of the substation transmission line. Incoming feeder protection devices, busbar selection, measuring instrument, transformer VCB, switch gears and outgoing feeders line. So first of all, we are going to draw the electrical circuit diagram in AutoCAD Electrical as per the substation for our better understanding and for the project guidelines for the further upgradation. This is a site view. This is incoming feeder coming from the 132 line step down to the 33 kV, then further going to the 33 kV incoming feeder. We are going to see the 33 kV transformer here, which is a step down transformer which we are going to see further. This is the measuring instrumentation and this is the description of the transformer. As per this image, we are going to see this transformer is a delta to star transformer. Star is connected with the neutral line for the further upgradation. These are the other details of the transformer, which shows the MVA of the transformer, incoming and outgoing feeder and current capacity of the transformer. As per the video, you are going to see this is the bus bar incoming as per the size of the conductor. This is the outgoing size. This is a step down transformer 33 to 11 kV transformer. As per the AutoCAD drawing, here we are going to see the some switch gears and VCBs and other parts. This is the isolator, disconnector. This is the indoor line, outgoing feeder. This is a transmission line. This is a VCB, vacuum circuit breaker. Upper side of the vacuum circuit breaker, which is connected with the CT and PT, we are going to see in further. And this is the all manual disconnector of the circuit breaker or isolator. This is the earthing where we provide with the water tap for the moisture. This is APMC drawing of the AutoCAD Electrical. APMC used for automatic power factor controller. This panel is under future expansion, so we are not going to discuss it further. So let's just discuss and go through with the measuring instrument. This is a thermocoupler. Socket is connected. Terminal blocks are connected with the according to the application. All the measuring instruments are connected in the panel for the front view. This panel is a rear view panel which opens with the back, and the measuring instrument is connected for the front view. This is a back end connection of the panels. We are going to see the further front view of the panel. Let's see. This is a front view of the panel which shows the APMC, all measuring instrument and the indication for the lights and the MTR meter trip relay. This is a BOM, bill of material and a symbol representation. In this drawing, we are going to see the off-site visit. The VCB closed video. Here we are going to see the CT current transformers connected with the series and the PT potential transformers connected with the parallel with the VCB with control panel and measuring instrument. This is a switch gear VCB part, which is motor operated spring operated VCB with the terminals. The outgoing feeder and the incoming feeder. This is the incoming feeder control panel which is connected with the control room. This transmission line going further with the isolator connection, again from the isolator to the next outgoing feeder of the VCB. Isolator is used for the disconnection part for the maintenance of the any of the VCB or a switch gear. So we are manually going to disconnect the portion and work on the maintenance. Next, this is VCB switch gear, spring connected motor shaft for the VCB disconnector, which connected with the isolator. Further, in this panel, we see the terminal blocks and the spring connection of the motor. This is the APMC panel, automatic power factor control for the 1, 2, 3, 4 disconnector of the transformer and the other power factor controller. This is a 1, 2, 3, 4, which is connected with the APMC, and this is the new upgraded SLD single line diagram of the substation, which is connected, included all parts of the substation. I hope you guys get all the inside of the substation and SLD as per the project and the viewing of the all components in the transmission line. Thank you for watching this video.